Let's explore blockchain and distributed ledgers, which are also known as immutable database technologies. These are decentralized systems designed for secure, transparent, and tamper-proof data storage. In coming slides, we will learn more about them. Let's understand what exactly a blockchain is. It is essentially a distributed digital ledger that records transactions across multiple computers. This design makes it extremely difficult to alter, hack, or cheat the system. Blockchain technology is characterized by being decentralized, immutable, and transparent. Let's review the key components that make up a blockchain. First, blocks. These are the data containers that store transaction information and metadata. Second, cryptographic hash, which is a unique digital fingerprint that ensures data integrity and security. Third, distributed network, which is a peer-to-peer network of nodes maintaining the blockchain. Fourth, consensus mechanism, which is a protocol for agreeing on the validity of transactions. Let's take a closer look at the structure of a block within a blockchain. Each block consists of several key parts. First, the block header, which includes information like the previous hash, Merkle root, and timestamp. Second, transaction data, which is the list of verified transactions included in the block. Third, block hash, which serves as a unique identifier for the specific block. Fourth, nonce, which is a number used once during the mining process. Let's explore distributed ledger technology, or DLT, by comparing distributed systems with centralized systems. In a distributed system, there is no single point of failure, data is replicated across nodes, validation is consensus-based, security and transparency are enhanced, and it operates on a peer-to-peer network. On the other hand, a centralized system has a single point of control, a central authority manages data, trust is required in the intermediary, it is vulnerable to attacks, and it uses a client-server architecture. Let's discuss consensus mechanisms, which are crucial for the operation of blockchains. Some of the key consensus mechanisms are proof of work, where miners compete to solve computational puzzles to validate transactions and create blocks, proof of stake, where validators are chosen based on their stake in the network to validate transactions, delegated proof of stake, where token holders vote for delegates who validate transactions on their behalf, and Byzantine fault tolerance, which ensures consensus even when some nodes are malicious or fail to respond. Let's discuss immutability and security of blockchain. The security features include cryptographic hash linking, distributed consensus validation, tamper-evident records, digital signature verification, and timestamp transactions. Because each block references the previous block, each block contains previous hash, data, timestamp, and a nonce. A unique hash is calculated. Let's explore various applications and use cases for blockchain technology. These include cryptocurrencies, which are digital currencies enabling peer-to-peer transactions without intermediaries, supply chain tracking, to track products from origin to consumer, ensuring authenticity and transparency, healthcare records, for secure interoperable patient data sharing across healthcare providers, and digital voting, for transparent, verifiable elections with immutable vote recording. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.